Have you ever wondered why on a long haul flight, the little map shows the plane flying along a curved line instead of just a straight line from point A to point B? Why is the plane wasting so much time, fuel, and energy flying along this curved line instead of just going from point A to point B? Let's find out. Hi, I'm Grant and welcome to the third class in the Gnav series. Today we're going to be looking at great circles and rhumb lines, what they are and what the main differences are between the two. The shortest possible distance between 2 points on the surface of the Earth is what is called a geodesic. A great circle will connect 2 points in the shortest possible distance on a perfect sphere. So that means that on Earth, a geodesic and a great circle are slightly different, because a great circle only applies to a perfect sphere and the Earth is not a perfect sphere. But in ATPLs and in aviation in general, we like to simplify things. So we kind of ignore this squish nature because it's only minuscule, and we would call a geodesic and a great circle as being the same thing. So great circles, by their very nature, have to have their center at the center of the Earth. So it means at some point they must cross over the equator. And this point that happens is called a node. And where the great circle reaches its highest or lowest latitude and then starts returning back down the other side, we call this highest point the vertex. So due to a great circle being a straight line on a curved surface, the track of the great circle is variable. It's constantly changing. So what do I mean by that? If we take a look at a top-down view from this point A to this point B, we start off with a track always referenced to north of 30 degrees. And you see, as we travel along the line of the great circle, the reference point of north slowly comes round, but we still reference it to north. So about halfway, we're looking at the great circle track of being about 90, and then out the other side at B, it's going to be much larger than 30. It's going to be much larger than 90, and that's what we're going to look at in the next class, how to actually calculate this value. So because the great circle doesn't cross every line of latitude at exactly the same angle, that means that its direction is constantly changing. And if you think of this as a map where north is always up, if you've got a constantly changing track, you would see a curved line, which is why when you look at the progress maps on long haul flights, it appears to be a curved line that you're flying across. It's actually a great circle, but instead of changing the reference for north like we're doing in this case, the reference from north stays the same and our line curves instead. A rhumb line is a line that connects 2 points with a constant track. This is the main difference between the great circle and a rhumb line. It makes it far easier to fly, as you don't need to constantly change your direction to fly along the great circle. You just pop in one track and then you fly along it. But it is a longer route, apart from the only cases are if you're at the equator and if you're following a meridian of longitude. At that point, a rhumb line and a great circle are the same thing. So in this example here, the simplest rhumb line would be to follow a line of latitude around. So you'd follow the line of latitude around like that, heading purely east or purely west if you're starting at B. You can clearly see just from this example that that line is a lot longer than that line. And this difference is more obvious the further from the equator you go and the larger the change in longitude. So a very quick one today, but in summary, geodesic is almost exactly the same as a great circle, but there is a difference because a geodesic is on Earth with that slightly squished nature and a great circle is a perfect sphere. We think of them as being equal for aviation. When it reaches its highest point, it is called a vertex. And when the great circle crosses the equator, that's called a node. And the great circle being the shortest distance between 2 points on the surface of the Earth, that means that if we follow a great circle, Our track is always meant reference to north, so our track is going to constantly change as we fly along the Great Circle. We're always going to have our compass pointing north, and as we move along, it's going to constantly point north and our track is going to change. The opposite to that, or something a bit different, is a rhumb line. Rhumb lines follow the same track the whole time, and the easiest way to think of it is just following a line of latitude from one point to the other. At the equator and along the lines of longitude, a rhumb line and a great circle are actually the same thing.